This film introduces the A-0-B Symmetry Theory and its new way of looking at the foundations of physics. The theory suggests a universal symmetry principle that governs everything from the tiniest particles to the largest structures in the universe. It offers a single description of quantum phenomena, gravity, and how space-time came to be, possibly eliminating the need for ideas like dark matter and dark energy. The A-0-B theory provides a consistent mathematical formula connecting the quantum and classical worlds, offering explanations for phenomena ranging from quantum entanglement to how galaxies rotate. By reinterpreting fundamental concepts like time, cause and effect, and the nature of physical laws, this theory opens new doors for theoretical physics and experimental verification, promising a major shift in how we understand the universe.
The theory assumes that the speed of light is constant for everyone, no matter how they're moving relative to each other or to the objects being observed. This fundamental assumption of special relativity is kept by the A-0-B theory. The A-0-B Symmetry Theory assumes that measurements in quantum systems always happen in the present moment. This is key to understanding the quantum aspects of the theory. The A-0-B symmetry is a fundamental property of space-time itself, underlying the structure of the universe. Space is the field of A-0-B symmetry. Local disturbances of the symmetry field are the source of condensation, leading to the emergence of material structures and gravity, or its expansion, leading to the emergence of antimatter and anti-gravity.
The concept of A-0-B symmetry assumes absolute simultaneity. The distance AB at the time of measurement is always equal to the distance BA. If this is the case, the events at points A and B are simultaneous. At the time of measurement, the distance AB must be identical to the distance BA. This is regardless of the relative motion of points A and B to each other, because the measurement occurs in the present, and the constant speed c is the same for both points, regardless of their relative motion and speed. According to the assumption, there is one distance and one signal speed c for both points. The speed of light is an element that defines the simultaneity of events at points A and B, regardless of their position in space. This is a groundbreaking way of thinking about simultaneity. The 0 point is understood as the center of symmetry of points A and B, which, as we'll see soon, has big implications for how space is structured. The symmetry of points A and B with respect to the center of symmetry 0 is universal. It exists on all scales, forming a self-similar structure of reality.
Quantum mechanics in the light of symmetry. The A-0-B theory assumes that Heisenberg's uncertainty principle comes from the way we measure things, not from the inherent properties of particles themselves. Imagine two particles that interact, then are separated and sent in opposite directions. According to quantum mechanics, these particles can be in a linked state, where measuring the properties of one particle instantly determines the corresponding property of the other, no matter how far apart they are. The EPR experimenters were surprised how the result of the measurement on one particle could simultaneously affect the properties of the other, violating the principle of locality in physics. This seemingly instantaneous influence, regardless of the distance between the particles, led Einstein to call this phenomenon spooky action at a distance. The paradox here arose from the conflict between quantum mechanics and the principle of local realism, which states that the physical properties of objects exist independently of observation and that influences cannot travel faster than the speed of light. Here is an interpretation consistent with the A-0-B theory. In the EPR paradox, we have discovered a hidden symmetry that has been overlooked by both EPR thinkers and later physicists. This unrecognized symmetry lies in the geometry of the experiment and consists in the fact that particles A and B, after separating and moving at identical speeds relative to the point of separation, remain in the same present relative to each other and to this point. The conclusions I draw are a consequence of the previously mentioned definition of simultaneity. Since the particles are entangled, remain in the same symmetrical geometric relationship, and in a common present, the simultaneity of subsequent modifications of their quantum states should not surprise anyone. So, measuring one particle doesn't send information to the other. Instead, it reveals the already existing symmetrical relationship between both particles with respect to the point and time of separation. This point is the center point 0 of A-0-B symmetry. The solution to the EPR puzzle became a turning point and served to lay the foundations of A-0-B theory.
Gravity and cosmology. The A-0-B theory offers the potential for unifying gravity with quantum mechanics. The expansion of the universe is explained here without the need to introduce the concept of dark energy. The theory also offers a new solution to the problem of flat rotation curves of galaxies, potentially eliminating the need for dark matter. The theory introduces the component of anti-gravity as an equivalent repulsive force into cosmology, allowing an attempt to unify fundamental forces. Implications. Space-time becomes an emergent property arising from the fundamental symmetry. The curvature of space-time is interpreted in A-0-B theory as a local disturbance of this symmetry. This approach made it possible to move away from the concept of gravitational waves propagating at the speed of light. The model of symmetry condensation to explain gravitational phenomena naturally connects with the three-dimensional model of the A-0-B symmetry field. Quantum entanglement, gravity, and anti-gravity may be different manifestations of the same fundamental symmetry. Extended to three dimensions, the symmetry of the A-0-B theory offers a unified explanation for both quantum properties like spin and gravitational phenomena like the perihelion precession of Mercury, eliminating the need for separate theories for different scales.
Matter and antimatter. Matter arises from the condensing component of A-0-B symmetry. Antimatter, on the other hand, arises from its expanding component. This explanation offers a new perspective on the asymmetric ratio of matter and antimatter in the universe, which could be closely related to the observed expansion of the universe.
Philosophical implications. The theory suggests that the same symmetry principles could govern reality at both the tiny and cosmic levels, as well as real and virtual universes, which has profound philosophical implications. It also offers a new perspective on the nature of time and causality. An interesting aspect of the theory is the proposed universality of symmetry, which would be a fundamental element creating every reality.
The unifying potential of the theory. The A-0-B theory offers a framework not only for unifying quantum mechanics, gravity, and fundamental forces, but also for building a bridge between physical and virtual reality. The A-0-B theory is well-founded and consistent with current scientific observations and discoveries, from quantum phenomena to cosmic structures. The theory assumes that worlds that exist as algorithms are subject to the same fundamental A-0-B symmetry transformations as our reality, suggesting a deep connection between computational processes and physical reality. The development of advanced simulations and models to test and refine the theory, with a particular focus on investigating the universality of the A-0-B transformation in different types of systems, including algorithmic and virtual realities, seems to be only a matter of time. In summary, the concept of A-0-B symmetry as a fundamental and self-repeating principle underlying all realities suggests a deep, universal structure that may explain the emergence of known physical laws, dimensions, and even consciousness. This idea uniquely connects quantum mechanics, information theory, and cosmology, offering a path towards a unified understanding of reality. The implications of this theory go beyond the present universe, suggesting a framework for understanding all possible realities, including virtual or simulated ones. This universality is perhaps one of the most exciting aspects of A-0-B theory, as it opens up new avenues for exploring the nature of being and its origins. Thank you for your attention.